Can you think of an example of an annuity? Payments that you make that are equal over a fixed period of time. Does that remind you of anything? Car payment. You guys are too young to have a mortgage, but car payment would be an example. Or, when you graduate, you have student loan payments. Similarly, all right? Now, the issue is how do we calculate the value of that? I'm not going to derive the formula. You should have seen it in basic finance. I'm just going to write it down. I'm going to make an argument that it is an extremely ugly formula. And as you may have gotten a hint last time, I do things civilized way, okay? I don't do ugly. So we're going to do it beautifully. So present value of an annuity. Let's make sure that now it's Lauren as late. Present value of annuity. So let's have the notation. R is interest rate using APR convention. If there is more than one payment during a calendar year, APR is basically multiplying the period interest rate with the number of payments. For example, an APR of 12%, if payments are monthly, means every month you're paying 1% interest, okay? That is not the effective annual rate. That would be something else. I'll show you how to calculate it. It's easy to do. But interest rates by convention are quoted as APRs. So if you're going to do all our calculation as APR, if somebody tells you the effective annual rate, we have an easy way to convert that into APR. F is frequency. Number of payments in a year. So monthly it would be 12, quarterly 4, weekly 52, so on and so forth. T, number of years of payments, could be non-integer. $C is the periodic payment. I'm going to have also a $B. This is a balloon payment. It is unlikely you will see something like this for car loans and mortgages, but there are annuities that are cash flow systems that look like annuities with a balloon payment. One example would be a treasury bond. Every 6 months, it pays you a coupon, and at maturity, it also pays you what we call a face value. So that would be an example of a balloon payment. So if we're careful ahead of time, set up our system to include that as well. When it's time to value bonds, all I have to do is go back to the work we have done for annuities, right? If there is no balloon payment, you're just going to put it as 0. Okay, and present value of an annuity. Formula, annuity with balloon payment equals $C divided by R over F. R over F is basically the interest that you would pay in a single period times 1 minus 1 over 1 plus R over F raised to the power T times F. Can I have a hallelujah to this statement that says this is ugly? Trust me, there is even uglier stuff. When we're doing present values of growing annuities, it gets even uglier. That first part is the present value of the equal payments, okay? To that, we're going to add the present value of actually 1 plus R over F raised to the power T times F. And, all right. So let me highlight this with a different color. The pink part is present value of the balloon payment. And turquoise part, or you may call it teal, right? I don't know why I couldn't create a space, but and it literally means as it is in Turkey. That's the color of sea in the Aegean Sea. Okay, it's not a problem. We can code this in Excel. There are kind of a lot of traps. One, you need to worry about order of operations. Be careful of parentheses. For example, if you wrote that 1 plus RF raised to the power T times F as 1 plus R divided by F, close the parentheses, to the power without the parentheses, T times F, you're going to make a mistake because exponentiation takes precedence. That means 1 plus whatever is going to be raised to the power T, not T times F as you want it. Okay? It's not that big of a problem to be careful about it and do it, but we're civilized people. If I don't have to do it, why should I do it? All right? Now, Excel has a function, is a built-in function that calculates the PV of an annuity with their balloon payment. And it's called PV. It has a few arguments. The first one is the period interest rate, number of periods, periodic payments, and balloon payments. That last argument is actually optional. If you don't include it, it's assumed that it's zero. Right? There's even a fifth argument. It's the annuity type, but we're not going to deal with that. Technically speaking, there are two types of annuities. One is called ordinary annuity, which is things like mortgages, car loans, and stuff, where the first payment is made at the end of first period. So if you're making monthly, you're going to make your first payment 1 month after you bought the car and financed it. The other is called annuity due or annuity in arrears. The first payment is made right now. The only example that you can think of that would apply, if you get one of those Powerball jackpots, you have two options. You can get a lump sum now, or you can get paid over 30 equal installments. The first installment is made right now. But an ordinary annuity is a cash plus, annuity due is cash plus an ordinary annuity with one less period. That's it, if you think about it. We can use that function to handle it, but I'm not going to worry about it. All right. Now, we will also talk about future value of an annuity. With a starting balance, or let's call it beginning balance. Here, $B is going to be beginning balance. So if I have $10,000 now, and I'm going to save $100 a month for the next 40 years, and I could earn 8% APR on it, how much money will I have in my account 40 years from now? That's the future value. Okay. Basically, it's the value of a bank account that makes periodic contributions, and it has a starting value that earns a constant interest rate. And future value of annuity is also simple. In fact, I'm going to take this and make, okay, now